Hello everyone. In this particular video, we are going to learn the concept of zero temperature drift concept of JFET. The concept of zero temperature drift concept of JFET. The meaning of this particular topic is that we are trying to bias JFET in such a way that even if the temperature shifts by some amount, there will be negligible effect on ID, that is output current of JFET. So that is our intention. So for that we need to understand this concept very well. And self-bias circuit plays a very significant role when it comes to zero biasing concept of JFET, zero temperature drift concept of JFET. Okay, so these are the prerequisites of this concept. So let's understand this concept in detailed way. But first of all, I would like to explain you this internal structure of JFET. And these are electrons and these are the lattice atoms, or basically you consider it as a lattice crystal or atoms, just an atoms. Okay, so now we will see it's working. This is a short animated video from my side to you all guys, so that you can understand this concept very well. Okay, so we will see this. See, as the electrons are moving. Okay, this happens when we provide positive voltage to drain terminal. Okay, see, the electrons are moving, and as you can see, wait, I will just, okay, so as you saw here, sorry, that most of the majority of electrons were able to pass through these atoms. Okay, in a normal condition, that means there wasn't any effect of temperature, in this case. Okay, and majority of electrons, let's say here 1 4 4 8 9 10 11 12 13, okay, 13 electrons were able to pass from source to drain. That means ID, we can consider ID as ID max in this condition. Okay, we can consider ID as, that means output current or drain current, as ID max. Okay, but now as we move to the next animated video, okay, so effect of temperature on JFET. Okay, so we will see this animation. Okay, so now see, as temperature increases, the lattice atom starts to vibrate. Okay, it starts to vibrate, and now you can see there are majority of electrons got stuck because of the vibration of atoms. Okay, see, majority of electrons got stuck, and only 4 electrons were able to pass from source to drain. That means the output current, or ID, basically is decreased, or we can consider ID to be ID minimum. Okay, ID minimum or ID decrease. So what we learn from this concept is that as the temperature increases, okay, but I will use some rough paper. Okay, as the temperature increases, ID, that is output current, drain current, decreases. Okay, and vice versa case happens. That means as temperature is decreased, the ID is increased. Okay, so what does that mean? If we plot the transfer characteristic, it's something like this. I will try to explain you in much easier way. Okay, uh, okay, so what does that means? As the temperature is increased, that means, let's say if it is ID, it this is a point for ID. Okay, this is a point for ID, and if temperature is increased suddenly, if temperature is increased, okay, then ID should decrease to this point. ID should decrease downside. Okay, but ideally this should happen, but practically, it doesn't happen. Why? This is because of self bias circuit. If you remember, in the earlier video, or in my earlier post, I had explained the concept of self bias circuit. And if you don't know that concept, then please do visit the post. The link of that post, I had provided it in the description box. Okay, and from the self bias circuit, we got one equation, that VGS is equals to minus ID into RS. Okay, VGS is equals to minus ID into RS. Now if so here it is minus VGS, and this is IDSS, this is transfer characteristics. Okay, now see, if ID is decreasing, okay, if ID is decreasing, that means VGS is tending towards 0 volts. That means VGS is becoming positive. Okay, just a second. Yeah, VGS is becoming positive. This, let's say this is a number line system 0, and this is negative side. So as our ID decreased, as you can see, so VGS tending towards this side. Okay, VGS is becoming positive. But now let's say if the temperature is decreased, and if ID, okay, if ID is increased, if ID is increased, that means VGS becomes more negative. VGS becomes more negative. That means in this number line system, it will try to move this side. Okay, and in this case, when VGS, I mean the ID was decreasing, so VGS was tending to move this side. Okay, VGS was tending to move this side. So this particular condition resembles this, and this particular condition uh, resembles this one, that VGS is moving towards more negative. So the ideally, what I told you earlier, ID will move downside, but VGS will pull to the upside. VGS will pull it upside. So therefore, at the end, it will somewhere remain at this point only. Okay. So this is the whole idea about how the effect, like what is the effect of temperature on the output current of JFET. So this was the whole idea, and I hope you understood up till now. And now I will try to explain the equation. I mean, little mathematical form. I won't be going in that mathematical form, but still for your better understanding. So as we saw that if the temperature increases, then ID decreases. Okay, and if temperature decreases, then ID increases. So now the change in ID, that means when the temperature is increased, I will take this condition, that means del ID1 I will consider is equals to, experimentally it is found that as temperature increases, ID decreases by 0.7% per degree rise in temperature. Okay, ID decreases by this amount. Okay, and I will use some different color. As the temperature increases, then del ID2, I will use this nomenclature del ID2. Del ID2 will change by 2.2 millivolt into GM, transconductance, that is millivolts on 10 raised to minus 3. So these are the experimentally calculated values. You don't need to worry as such for now. So as the temperature increases, ID decreases by this much amount, and as the temperature decreases, ID increases by this much amount. Okay, so now we want a certain point where ID is totally independent of temperature. So we consider this equation. As you can see here, when we equate this to equation, that means when when uh, it is decreasing ID with respect to temperature and increase in ID with respect to temperature. So when we actually equate this to equation, we get Vp minus VGS is equals to 0.63 volts. You don't need to worry about it. I had provided this image in my post, and the link of that post I had given in my description box. It's a simple mathematical calculation. I hope you will be able to do that. Just have to equate the equation, and at the end you get this equation, Vp minus VGS is equals to 0.63 volts. So this particular equation is very much important to understand, to clarify the whole of this concept. Okay, so I'll zoom it out. Okay, so now as you can see here, this is the VGSQ, this is IDSQ, this is IDS and VP. So what does that means? We got one equation, that is VP. We are writing it in mod because all these values are negative, and this was VGS is equals to 0.63 volts. So let's suppose uh, the what does that means is the difference between VP and VGS at certain point. So this whole curve represents VGS. So at certain point it should be 0.63 volts. That means if we somehow manage to keep the VGS at 0.63 volts from VP, okay, then we will see negligible effect on ID with respect to temperature. That means even if the temperature increases or decreases, okay, even if the temperature increases or it decreases, but there won't be any effect. There won't be any effect on ID. That means ID totally is independent of temperature. Okay. So that was the whole idea behind the designing this, or basically the concept, designing the circuit, or basically biasing techniques to make ID independent of temperature. And another thing is that even if, let's say, if VP in earlier case, if VP is minus 3 volts, so VGSQ or basically VGS will be, or VGSQ will be somewhere around, if we error to 2.4 volts, somewhere around minus 2.4. Okay, so it is I will write over here, it is minus 2.4 volts. Okay, now if VP changes by some amount, let's say if VP becomes minus 4 volts, so VGSQ shifts accordingly. That means around 3.4 volts, minus 3.4 volts. That means VGSQ also shifts accordingly. As VP changes, VGSQ also changes. Okay. So this was the whole idea behind designing the whole concept of, behind designing the biasing circuit, and that's why we required uh, biasing of JFET to make ID independent of temperature. And as you can see, this is a curve. Wait, I will little zoom out. So as you can see, T1, as the temperature is decreased, ID is at its maximum value. When temperature increases by certain amount, okay, the ID decreases, and when the temperature increases maximum, then ID decreases by maximum amount. But we get a certain point, we manage to get a certain point, okay, that is, as I told you in this case, that is this one, see, modulus of VP minus modulus of VGS is equals to 0.63 volt, and due to this we get this point which is totally independent of temperature. So I hope you understood the concept. So this is what I wanted to explain you through this whole video. I hope you understood this concept. So at the end, I will again like to show you this animated video I had made. So there won't be any doubt after seeing this. See, as you can see, electrons are moving slowly and steadily. This is a normal condition, and majority of the electrons are able to pass, okay, to the drain terminal. Now as the temperature increases, the atoms start to vibrate. Okay, due to vibration, majority of electrons got stuck in these atoms, and only few electrons managed to pass out of it. Okay, you can also remember this concept in a form of defender and striker. For example, goalkeeper. So you can assume this atom as a defender and this as a striker. So if defender are stationary, then for striker it will be very much easy to pass the ball to the goal. So in this case it will be very much easy for the electrons to go up till drain terminal, while in this case if the atoms are not stationary, that means if defenders are not stationary, they are moving, then it will be very much difficult for the striker to hit the ball to the goal. And similarly in this case for the electrons, it will be very much difficult to reach the electrons up till drain terminal. So this was the whole idea. So I hope you like the video. If you like it, then please do like, share, and subscribe my channel. And at the same time, please do visit the post which I had uh, given in the description box. It will help you to understand the concept in much better way. Thank you.